All right, so a bunch of you would have had, well, technically half of you would have had lab yesterday, right? So hopefully that went well. Hopefully you were able to get some work done. I'm just going to go ahead, right? So we aren't having a quiz this week. We'll start having quizzes next week, as well as some in-class exercises to do. Last semester I tried, I guess flipping it pretty naively, which was that I wanted to, I gave you the lectures to watch, and then you would come into here, and there would be basically nothing to do but work on the homework. And from what I understand, the more useful thing to do here is to come in here and also work on in-class exercises. And all those in-class exercises, they count as quizzes. So the way that works is typically you just turn something in, and if you turn something in and it looks approximately right, not like that it works, but you tried to get something done, we give you credit. It's kind of a participation grade. So then the quizzes themselves, most of them that I give out, those are auto-graded. Most of them have a point, have about 40% of the points or more given to you for free. Other questions that we do in quizzes are what we call parson puzzles, where basically I ask you to program something, but programming something on an automated quiz is a bit hard, right? Especially if I want to auto-grade it. So what I have you do is I have you arrange the lines of code in order. So you're given a drop-down menu and you simply arrange the lines of code in order. There's a couple of distractors in there, so there's 8 slots to put stuff in and there's 10 items, right? And the most annoying thing in there is that it's not always properly indented, so I have to say, okay, this curly brace ends an if statement, this curly brace ends the for loop, so that can get a bit annoying, but it works, it works, and it's a bit less stressful than having to try to code something from scratch. All right, so that's kind of the way the quizzes will go, because I do try to make this as easy as possible for everybody. All right, so I just want to go through this and just talk about a bit of strategy. So hopefully by this point you've been able to get your rabbit to see the fox, and if so, react and move away from the fox in some way or form. If you're at that point where basically even if it's not a winning strategy yet, as long as you're seeing the fox at this point and then moving in response, either away from the fox or accidentally towards the jaws of death, either of those, as long as you're reacting, that's good, okay? So let's just go ahead and see how we can help with your survival strategies. So when I started this, the rabbit was right over here, okay? And what happened was the fox saw the rabbit, and now it's moving towards the rabbit, and the rabbit randomly moves, and it randomly decided to move to this direction, okay? So right now, the rabbit is out of the line of sight, and it's the rabbit's turn to move, and he just simply moves back there, okay? So now the fox sees the rabbit. He looks around, he sees the rabbit, and he says, I'm going to move towards the rabbit. Now it's the rabbit's turn. I have him looking up, and that just doesn't do anything, by the way, and he decided to just stay put. I think he tried to move this way, which means if you try to move into a random direction and you can't move, right, if the decide move returns an illegal move, it's just going to stay put. So now he's moved out this way. Now notice that the rabbit just moved out of the line of sight of the fox, but the fox's algorithm says, oh, if I can't see the rabbit, right, I can't see the rabbit, so I'm just going to move towards the last known position of the rabbit, okay? Now, it can't, but it's out of line of sight, even though it's straight ahead here. It's out of line of sight because the line of sight for the fox is this vector over here and this vector over here, right, as well, and of course it's mirrored, right? But we're just going to deal with this to keep it simple. It's this over here and this over here, which means this entire cone over here is like a safe spot for the rabbit to kind of just dodge out of sight. And of course, because it's random, the rabbit's doing a pretty poor job of just basically running away, right? But it's going to run to the last known position of the rabbit, and the rabbit's still out of line of sight. But one thing you can do is just use the fact that basically you can get out of the line of sight pretty easily. Also, the turns are not, simultaneous, right? They take turns. So it's possible for the fox to look around, move here, and, it just moved into the line of sight of the rabbit, but it doesn't see the rabbit yet. It's got to wait till its turn to see the rabbit again. So then the rabbit can see it and then move out of the line of sight, right? So it's possible that essentially the fox can come in, see and not see the rabbit, and the rabbit just moves away from it and stays hidden, essentially because of the mechanics of the game. Okay, so that's one thing to note. So that's strategy number one, which is actually a very successful strategy if you just simply exploit if you think about the lines of sight and what would make your rabbit live the longest, you can come up with a very successful strategy that will survive, depending on how you code it, 70 to 90% of the time. It's pretty successful, which translates to a pretty high grade. The other strategy that also works is to use the MMORPG term, kiting, which means that and that comes from a tactic in these mass multiplayer role-playing games where one player engages the enemy and basically says, "Here, come and eat me," right? Big scary monster, basically he, maintains he has the monster chase after him while the rest of the party whittles it down. Now, in this strategy here, kiting would mean that you have the fox chase you because you can both move at the same speed, and you just simply have it run after you for 100 turns, right? Now, that would just mean you'd have to maneuver around obstacles. That's not too bad in here, right? What you would do is that basically you'd get to an edge, and then you can just simply skip over here because you don't want to get into the corners. And then you can run over here, you can move around that bush, right, and go back to the corner and do the same thing. And you can just continue hugging the edge, except for the corners, and just make your way around any bushes that are there, right? It's not too bad of a strategy. There are some edge cases, like what if you have a bush here and a bush here? But otherwise, you can program around those. But it's a strategy. It's not the strategy I use, but it's a strategy you can use if you want to. There's a lot of different strategies that work here. But those are basically the two categories of strategy. And of course you can mix and match if you really want to. So those are the overall strategies there. Just because I had gotten this in a number of emails, how do you check to make sure what how successful your strategy is, right? Rather than just running Fox a bunch of times. There is a grader.java file that I've provided for you, and that's the same one we're going to use to grade you. So just simply compile that and run it, and it will tell you their survival rate, right? And since I'm using, the only thing I've done here is just made it look up and just not do anything about that, then it's going to tell it, right, it doesn't survive much at all, right? But once you start just actually doing things, it will do much better. All right, that's really all I have for today. And again, I sent out the videos on right. I told you to watch the first 5 videos, which basically 4 of them go over polymorphism and inheritance. I do try to keep them below 15 minutes most of the time, but this was like the first batch I was doing, and I wasn't particularly good at it. The for each loop one, that's a pretty short one. That just simply goes over the for each loop, which is a very, very useful and easy to use construct, and you'll see me using it a lot. The important thing to remember is, to take away from those videos, is that a rabbit is an animal, and as such, it gets all the things in here. It has the ability to use all the things in here. Now, it can't use the model, right? It can't directly call the model because the model is a private variable, not a protected variable. So it can't use that. So even though it has a model, it can't directly interact with it. It does have a row and column. It says do not modify the row and column, but you're perfectly able to do that, right? Because they're not private or protected. And then you have you just have these methods that are available to it. You can use this.look, which calls model.look. You have distance, this.distance, which gives you the distance to something. So you can look, if you see the fox, you can get the distance to the fox, or if you see an edge, you can get the distance to the edge. And then you have can move, which asks, can I move in a particular direction, right? Which is a very useful function. Right, and it says, and it's just a simple way of telling, is the move you can do legal? So that's pretty nice. And this decide move is what you're overriding here. The default behavior is just simply staying put, and you can stay put, right? That was something that was asked a lot on Monday. You can stay put just simply by calling returning model.stay. and that will just simply, not do anything, which is a lot of times a winning strategy. All right.